Factoring patterns. So now we have talked about greatest common factor, factoring by factoring with greatest common factor. We've also talked about factor by grouping, which is going to be 4 terms. We've talked about factoring our trinomials where our leading coefficient is 1, and factoring trinomials where our leading coefficient is not 1, which is where we use the bottoms up. Now, we're going to talk about our last factoring technique, which is going to be the patterns. And to be honest, I would look for these patterns before I looked at anything else. Well, greatest common factor, of course, but then after looking at the greatest common factor, if my polynomial is not a 4-term polynomial, then I would look for the patterns. So the order that I would go in is greatest common factor, always. Then look and see if it's 4 terms. If it's not 4 terms, then look to see if it's a pattern. If it's not a pattern, then it's going to be one of your other techniques, which would be the trinomials. Okay, so we have a perfect square trinomial, we have a difference of 2 squares, and we have sum and difference of 2 cubes. Those are the 3 different patterns we're going to talk about. So a perfect square trinomial, first of all, let's look at the name. Trinomial, it has to be a trinomial, which is going to be 3 terms. And when we say perfect squares, we mean the first term has to be a perfect square. In other words, you've got to be able to take the square root of it. And the last term has to be a perfect square, and which means you got to be able to take the square root of it as well. But sometimes we can take the square root of the first and the square root of the last, but it doesn't give us that middle term, so you've always got to check that. If you take the square root of the first and the square root of the last, then you've got to be able to multiply those square roots together and double it to get that middle term. If not, then it's not your perfect square trinomial, and you'll have to factor it using the other trinomial techniques. So let's look. Decide whether each trinomial is a perfect square trinomial. Well, the square root of x squared is x, and the square root of 36 is 6. So the first and last terms are perfect squares. X and 6 are their square roots. So now if we multiply 6 times x, we get 6x. And then if we double it, we get 12x. So yes, this is going to be a perfect square trinomial. And this is what I'm talking about. Take the square root of the first, square root of the last. Multiply them together. 6 times x is 6x. And then double it, and you get 12x. So yes, that is a perfect square. So let's look at this one. Square root of 9x squared is going to be 3x. Square root of 25 is going to be 5. So if we multiply these two together, 3x times 5, we're going to get 15x. And then if we double it, we get 30x, which is not going to be our middle term. So this is not a perfect square trinomial. So you would need to try to factor it using bottoms up. And if it doesn't factor using bottoms up, then it would be prime. So it's not a perfect square. Alright, so let's look at this one. We're going to do x squared plus 12x plus 36. I know that I can take the square root of x squared and get x. I know I can take the square root of 36 and get 6. But if I multiply 6 times x and get 6x and double it, I will get the 12x. So this will factor. And so since these two are going to be the same, now your perfect square trinomials will always factor into 2 identical binomials. Identical, same sign and everything. And what we do is we condense that into what we call a binomial square of that perfect, or of that identical binomial. So I would like for us to be able to identify a perfect square trinomial and go straight to the pattern of a binomial squared, putting its square roots in here. So let's try that. First, let's see if it's a perfect square trinomial. And we're going to do that by go ahead and doing the process. We should get a binomial square. So the square root of 16x squared is going to be 4x. Match the sign, the first sign. This sign's always going to be plus. If it's a perfect square trinomial, this sign always has to be plus. So you're going to match that first sign. And then the square root of y squared is going to be y. Now let's test it and make sure. 4x times y is 4xy. 4xy times 2 is going to give us 8xy. So yes, this is a perfect square trinomial. So we're good. Always check it though. Alright, let's try this one. We have a trinomial, and we can take the square root of 4m to the 4th by getting 2m squared. Match that first sign, and the square root of 1 is always 1. So let's multiply these together. 2m squared times 1 is going to be 2m squared, and if I double that, I do get the 4m squared, so that is good. Alright, let's try this one. Let's try this. We have a trinomial, and I can take the square root of 25x squared and get 5x, and I can take the square root of 9 and get 3, and I'm going to match that first sign. So let's multiply these two together. 5x times 3 is going to be 15, and then double it, I'm going to get 30. So I do not get that middle term. So I cannot factor this using that pattern. So what I would have to do is I would have to try a different technique. Now, there's nothing in common here, so I can't factor out a greatest common factor. So what I'm going to try is doing the bottoms up. So I'm going to multiply the 25 times 9. And I'm going to have x squared plus 50x plus whatever 25 times 9 is. I think it's 225. And this one's going to be a pain to factor because of these big numbers, but we can do this. Our signs are going to be plus and plus, and then we're going to think square root of x squared is going to be x. What can I multiply together to get 25 but add, because the signs are the same, together to get 50. So let's think about this. To get 225, we did 25 and 9. Well, that's not going to give us 50. In fact, we fall way short. So let's see if we can find something else. Let's see, 225 divided by 3 is going to give us 75 and 3, so that's not going to get it to us. So let's go somewhere in between there. What about 225 divided by 5? That's going to give us 45 and 5. So 45 times 5 gives us 225, and that also gives us 50. So we're going to do 45 and 5. And then don't stop there. Remember, we've got to divide out what we multiplied in. So we're going to divide each one of these constants by 25. And we're going to reduce. So 45 and 25 will both reduce by 5 and give us 9/5. And 5 and 25 are both reduced by 5, giving us 1/5. And then what we're going to do is we're going to bring the bottom up. So we'll have 5x plus 9 and 5x plus 1. And that's how we would factor that. So again, it can be deceptive. It may look like a perfect square trinomial, but once you test it out for that middle number, it doesn't turn out to be that way. So be careful with that. Alright, so the next pattern we're going to talk about is the difference of two squares. So factoring the difference of two squares, what you're going to do, this is just the process. Once you realize that you do have the difference, talking about the name of the pattern, difference means you have to have a minus sign. Of two perfect squares, you have to be able to take the square root of the first and the square root of the last. Now this is always going to be a binomial. So the difference of two squares, difference is subtract, 2 means I have a binomial, and squares means I can take the perfect square, or the square root of each one. Once you realize you have the difference of two squares, you're going to open up two sets of parentheses, put a plus in one and a minus in the other. Then we're going to take the square root of the first and put it up front, and the square root of the last and put it in the back. And that's going to be your pattern. So let's try this. I have a binomial. I have a minus sign. I can take the square root of x squared and I can take the square root of 9. So I have my pattern. So we're going to open up two sets of parentheses, put a plus in one and a minus in the other, and it doesn't matter which is which. And the square root of x squared is going to be x, square root of 9 is going to be 3, and then I'm done. Let's try this one. I have a binomial. There's nothing in common. I have a minus here. I can take the square root of y squared, and I can also take the square root of 16/25. So I'm going to open up two sets of parentheses, plus in one, minus in the other. Square root of y squared is y. Square root of 16/25 is going to be 4/5. You just take the square root of the top and the square root of the bottom. Alright, let's try this one. So I have a binomial, there's nothing in common, there's a minus sign in between. I can take the square root of 4x squared, and I can also take the square root of 1. Square root of 4x squared is going to be 2x, plus and minus, square root of 1 is 1. Alright, let's look at this one. I have a binomial. there is nothing in common here. There's a subtraction sign, so that is the difference, and I can take the square root of each one of these. So let's do our pattern. Open up two sets of parentheses, put a plus in one and minus in the other. Square root of 36a squared is going to be 6a. Square root of 49b squared is going to be 7b. Alright, look at this one. I can take the square root of 4 and 49, but I cannot take the square root of an odd exponent. So that gives me a hint as to there's something in common, and I think there's an x in common. So let's take that out and see what happens. So that's going to give me 4x squared minus 49. Now I have my pattern, so keep that x in there. Open up two sets of parentheses, plus in one, minus in the other. Square root of 4x squared is going to be 2x. And the square root of 49 is going to be 7. So don't forget that greatest common factor, especially if you don't have one of your patterns. So look at this one. This one's written backwards, and that's okay. You still have your pattern. Open up two sets of parentheses, put a plus in one and minus in the other. Square root of 49 is going to be 7, and the square root of x squared is going to be x. Or if you want to, you can rewrite this, but it's going to be a little messy, and I'll show you how to do it. So when you rewrite this, remember the sign in front of the number goes with that number. So you have a negative x squared plus 49. Now that is not the pattern because you've got to have the difference of two squares. So what I would need to do is I would need to factor out a negative 1. And then that's going to give me x squared minus 49, which is your pattern. And so you'll have x plus 7 and x minus 7. So if you want to rewrite it, you can, but I would just leave it like that. Alright, so the last pattern we're going to talk about is the sum and difference of two cubes. Now, notice it says sum and difference. Now, when we're talking about two squares, it had to be the difference, because if you have the sum of two squares, in other words, if I had x squared plus 49, that's prime. You have to have the difference of two squares, okay? Now, for the cubes, you can have sum or difference. And so what we're going to do is we're going to look for a binomial, because that's where the 2 comes into play. 2 means a binomial, and we're going to look for cubes, things that I can multiply together 3 times to get it. So a cubed and b cubed. Now, notice there's two different ones here, and that's because of the signs. And to get your signs right, you can remember SOAP. Okay? So, here's your pattern. If I see that I have the sum or difference of two cubes, what I'm going to do is I'm going to open up two sets of parentheses, one small, one big, one small, one big. I'm going to take the cube root of my first term and put it here. A times A times A gives me A cubed. And then I'm going to match that first sign, and I'm going to take the cube root of the second term and put that there. Once you get that first small binomial, you're done with your original problem. Don't go back. And then what you're going to do is you're going to take that first term and square it. Take the opposite sign, multiply the two together, always plus that second term squared. Okay? So, here's your pattern. Take the square root of the first, square root of the last. First one squared, first times last, last one squared. And remember your signs. Same, opposite, always plus. Same sign as your original problem, opposite sign as your original problem, always plus. So again, one more time. Take the square root, same sign, cube root. Take the cube root, same sign, cube root. Square the first, opposite sign, A times B, always plus, last one squared. Alright, so let's try it. So, first of all, do we have the sum or difference of two cubes? Well, in both of these we do, because x times x times x is x cubed, and 3 times 3 times 3 is 27, so I can take the cube root of both of these numbers. So, here's your pattern. Open up two sets of parentheses, one big and one small. The cube root of x cubed is x. The cube root of 27 is 3. use the same sign. Then take your x and square it, and use the opposite sign. And then multiply 3 times x and get 3x. Always plus, and then that last term 3 squared, which is 9. So, cube root of the first, same sign, cube root of the last. Square the first, square your a, opposite sign, multiply them together, always plus, square your last. Again, once you get this first binomial, don't go back to your original problem, just leave it be. So let's try again. Let's take the cube root of y cubed, which is going to be y, match your sign, the cube root of 8 is going to be 2. Now, we're done with this, don't go back. Take your first one and square it, use your opposite sign, multiply the two terms together, always plus, take your last term of 2 and square it. So let's try these two. There's nothing in common. Make sure you check that. There's nothing in common here. So we're going to open up a small one and a big one. The cube root of 125z cubed is going to be 5z. And the cube root of 1 is 1, and we're going to match the sign. Don't go back. So 5z squared is going to be 25z squared. Opposite sign, multiply the two together. Always plus, take the last one squared. Alright, so the one on the bottom, let me see if there's something in common, maybe a 4. No, okay. So, but there has to be something in common because 16 is not a perfect cube. What if I divided out a 16? Nope. Let's see, what's in common here, guys? 16 divided by 2 and 250 divided by 2. That's it. Alright, so there's a 2 in common, so we're going to take that out. So I knew that because neither 16 nor 250 were perfect cubes. So there is something in common here. So remember, always try to look for a pattern. And if it's not a pattern and it's a binomial, your binomials are either going to be patterns or they're going to be greatest common factor. In this case, it's going to be both. So I can factor a 2 out, and that's going to give me 8a to the third minus 125b to the third. Now I have perfect cubes, and now I can do my pattern. Alright, so the cube root of 8a cubed is going to be 2a. Match that sign. Cube root of 125b cubed is going to be 5b. Take the first one and square it. Whoops, let's square that. So 2a squared is going to be 4a squared. Opposite sign. Multiply those two together, so we're going to get 10ab. I'm going to need some room here. Always plus. Take that last one and square it, so we're going to have 25b squared. And there's your pattern. Now these trinomials, you may want to try to factor those, but when you do this pattern, this sum or difference of two cubes, that trinomial is prime, so it won't go any farther.